All right. Welcome everybody to our presentation. Today we'll be doing malice code in websites. So we're focusing on attacks on web pages. My name is Ahmed Qasim,
My name is Derek Jenkins.
I'm Rebecca Young.
My name is Shoaib.
and we'll be diving into attacks. So let's get started.
Awesome. So our first attack is the SQL injection. I guess a lot of you might be familiar with this. It was first brought up by this guy named Jeff Forrestal, who was the first person to ever talk about this publicly in 1988 while he was trying to write up a report on how to hack a Windows NT server. And attackers can use this attack to bypass authentication and access sensitive data in databases like your password, which we'll see in the what's it, demo later. This can lead to things like data corruption in the database and the general loss of information. And to show off how it works, you have this totally legit website with a login. And assuming we want to log in as some guy named guest, a guest user, and all we would have to do is put in this password, which would make the SQL query that we're about to send to the server always return true. So we can just automatically log in despite that not actually being the guest's password because this is the guest password, right? And technically, with our dummy website, you can literally put in any username you could possibly want, and as long as you have this password, you can still get in. Right. And for defenses, currently our code is for this is pretty vulnerable because it automatically inserts your username and password into the query and treats it as SQL code. If we instead use a prepared statement, we can instead the question mark here is where the username would go and basically make sure that the data is treated as data and not as an SQL query. So if we save and reload, it should no longer work. There we are. Yes, so on to the next attack.
Okay, the way let me share my screen and take you to like how this particular attack works. Okay, so CSRF attack was discovered around 2001, and the way it works is it tries to steal the cookies of already authenticated users and then try to perform some task on behalf of authenticated user, and that eventually can lead to the deletion of the user account, or some of the useful information of the user can get stolen because someone else is using the stolen cookies to perform an attack on us on and using and sending requests, forging requests to the website where we are already authenticated. And I'll like show how exactly this attack like works. So if I briefly show you on the terminal that we have a table on users that have their accounts on this particular like website, and if I try to sort of access the account of the last user, so the way it normally works is that I'll add a username, password, and try access that particular website. And there is a link which says click here to get your reward. And when I click it, I basically am redirected to some another website, and that website steals my cookies and try to delete my account. And now if I try to see the database after this attack has been performed, so I'll see that user has law account has been deleted when the user did not want to do it, but attacker stole the cookie and performed the task on the user's behalf. So this is how this attack works. And the defense for this particular attack is that we basically confirm, check the origin of the web request and make sure that it was not sent by our own website. And I'll briefly like show how it sort of like would work. So we basically add a condition, and check that we are the webs the that have not received the request from someone we don't want it to receive it from. And let's see, login dot. Okay, so now this time we are trying to log in again, and we sort of tries to click the account again, but this time our account, and I'll just like show the database again. And this time Alice account did not get deleted, and the way it works is that we basically add a check on the origin of the request. So this is how we can protect against this particular attack. So yeah, now we'll move to the next slide.
All right, so our next attack is XSS, or cross-site scripting. It was identified by security engineers in the early 1990s. Basically, in cross-site scripting, an attacker injects his or her malicious code in the victim's browser via a target website. So when the code comes from the website, it's considered trusted by the user. So it can access and change content on the page, such as reading cookies that belong to the user, and it could send out requests on behalf of that user. So basically, the attackers impersonate the users on the victim's machine by gaining access to their accounts. So some examples of this are, stealing sensitive data, defacing the website, redirecting users to unwanted websites, and performing actions not intended by the original user. And a classic example of this was the Sammy worm, which was the largest known cross-site scripting worm by infecting over 1 million MySpace users in less than 20 hours. So it was rather problematic at the time. And we're going to show off a demonstration of this attack.
So as you can see here, we have Jane Smith who's commenting on our social media website. And you can see that there's a hyperlink. So if anyone were on this website and they click the hyperlink, which we'll do right now, oh my God, no, our cookies just got stolen. And essentially, this is just a shorter version of the attack. We didn't, get into the rest of it, but the main focus is that cookies were stolen from us. And yeah, that's a bit it for this attack.
So another thing that might be important to note is that once a user posts this on the forum, everyone can see it. They can all see this post, and technically everyone has the option to click on this link and to get their cookies stolen. So there's another XSS vulnerability on this website, and it's here in the search bar. So if we type in, I'm gonna copy and paste it, it's basically just some HTML code with some JavaScript embedded into it, and then do that. It basically takes that search query and just executes it as HTML and JavaScript, right? And the way this website is coded, this is because it uses an inner HTML function call. And the function we call it when we press search, and it interprets the search query as HTML code. So any HTML elements inside our search string is rendered and executed. A secure way that's to prevent XSS would be to use this function instead, text context. Which this does not interpret any HTML tags. Instead, it treats everything as raw text, so we can't execute a script from the search string. So if we reload and try that again, okay, hang on. All right, ran into some technical difficulties there, but this will work. So if we take in the same JavaScript as we had earlier, we just search it up. Now it just takes it as straight text and doesn't execute any scripts. So that is a defense against XSS. And now back to the slides.
All right, so going over the broader lessons from this, as a developer, make sure when you take in inputs from users that you perform input validation. So make sure that your text is not being treated as data, because you should never just implicitly trust user input. Um, when you're setting up a user password system, it's always a good idea to set up, two-factor authentication so the browser doesn't just log in uh, on behalf of one user as the attacker. And then just some general common sense stuff. So just developer and user awareness. Make sure to download an ad blocker and never click hyperlinks that look suspicious.
Awesome. And we covered some of our defenses already in our demos, but again, one of the most important defenses against almost all three of them is to have prepared statements and to sanitize your input. It's incredibly important for like any user input to be treated as data instead of as HTML code. So that's pretty important. Same thing for XSS.
Thank you guys. That's our presentation.